In this video, we are going to look at how to create truth tables with two simple statements. So a truth table is a way to organize truth values by starting with the truth values for simple statements and then evaluating progressively more complex statements. So first of all, you have to understand how to figure out truth values for certain combinations of simple statements. So the first one is P and Q. The conjunction is true when both P and Q are true. So they both have to be true. Both simple statements have to be true in order for the conjunction to be true. The second one is P or Q. So the disjunction is true when at least one of the truth values are true. So if P is true, the disjunction is true. If Q is true, then the disjunction is true. If they're both true, then it's also true. But at least one has to be true for the disjunction to be true. The negation of P is true if P itself is false. So if P originally is false, then the negation of that will be true. The conditional statement, if P then Q, it's easier to think about when it's false. So this conditional statement is false when the antecedent P is true and the consequence is false. So if P is true and Q is false, then this total conditional statement is false. Otherwise, the conditional statement is true. And then finally, the biconditional statement. This is true if the truth values of P and Q match. So if P and Q are both true, then the biconditional is true. If P and Q are both false, the biconditional is true. So in this case, if the truth values match, then the overall statement, the biconditional statement, is true. So we're going to talk about constructing a truth table. So for this first one, there are a couple of possibilities. So in each of these, we only have two statements. We have P and we have Q. It gets more complicated the more simple statements you're dealing with. So if you're dealing with 3 simple statements or 4 simple statements, your truth table is going to be much more complex. But we're just looking at 2 simple statements. So what you want to do is think about every possibility that you could have. So let me make my truth table here. Okay, so a statement is something that is either true or false. That means that each statement has a truth value. So the statement P is either true or it's false. Same with Q. Statement Q is either true or it's false. So let's say P is true. Q could also be true. P could be true, but Q could be false. So those are the only possibilities if P is true. P is true and Q is true, or P is true and Q is false. Alternatively, P could be false and Q could be true, or P could be false and Q could be false. So they could both be true, they could both be false, or one could be true and one could be false, or vice versa. These are all the possibilities for these two simple statements and their truth values. You can always set up your P and Q this way. So your first simple statement will be true, true, false, false. And your second simple statement would be true, false, true, false. This will always give you a good base to build on. Then what you want to do is look at your statement. So I have not P. So next I'm going to add not P to my truth table. Remember that the negation is always the opposite truth value of what was originally there. So if P is true, then not P is false. So at this point, I'm using this column, P column, and negating that. The next P is true, so not P would be false. The third value under the P column is false, so then it would be true. And then the last statement for P is false, so the negation would be true. So the negation of P, if you set up P to always be true, true, false, false, the negation is always going to be false, false, true, true. So now that we have a not P column and we have a Q column, so we have a not P column and we have a Q column. Here's our Q, here's our not P. Once we have a column for each side of the larger statement, we can combine them together. So now what I want to do is make a column for not P and Q. So I'm going to be looking at not P, this column, and Q, this column. So at this point, I'm completely ignoring that first column P because that's not in my combined statement. So now what I have to remember is the symbol and, that's a conjunction. This is true when both are true. So when both are true. So each of the truth values in the columns that I'm looking at would have to be true in order for the conjunction to be true. So for the first row, I have a true under Q and a false under P. So since one of them is false, the overall conjunction will be false. Next, I have false, false, so that's false. Next, I have true, true. Here's where both of them are true. That's the only time the conjunction will be true. And then the last row, I have false, true, so that would be false. I don't need any of this other space. So I finally got to where I wanted to, the not P and Q. So that's what I'm looking for. That's it. Okay, so the next one, we're going to start by making our truth table with a P and Q. And we always start off with true, true, false, false, true, false, true, false. Always a good place to start. All right, and now you're going to start putting in other columns as necessary. So we're looking at each side of the disjunction this time. So on the left-hand side, we have just P. So we have what we need right here for that side. But for the second side, we have a not Q. We don't have a column for that, so we're going to work toward that. We have Q, so now we just need to add a column for not Q. This is going to have the opposite truth value of Q. So since Q is true, false, not Q will be false, true, false, true. This is what we need on the other side of the disjunction. So we're going to now compare these two highlighted columns. So we're looking at P or not Q. And since this is the statement that we wanted, that's going to be the end of our truth table. Remember that the disjunction is true if at least one is true. So in the first row, let me just label these. So we have 4 rows that we're looking at, right? In the first row, the P is true, so the disjunction will be true. In the second row, the P is true, so the disjunction is true. In the third row, P is false, so now I have to look at not Q. It's also false. That's the only time that the disjunction will be false. In the fourth row, P is false, but not Q is true. And so since I have at least one true, that one's true. So remember, the disjunction is true if either statement is true, and it's only false if they're both false. Okay, the third one, same starting place. We've got P and Q. True, true, false, false. True, false, true, false. Started off the same way every time because that covers every possible combination of truth values for 2 simple statements. And now we're going to add columns as necessary. So the first thing we look at is in parentheses. So we start in parentheses. In parentheses, I have P or Q. Well, I have both of those already. I have P and I have Q. So in the parentheses, I'm ready to go ahead and write that disjunction P or Q and find the truth value of that. So the disjunction is true if at least one is true. So the first row would be true. The second row would be true because P is true. The third row would be true because Q is true. And the fourth row would be false because neither of them are true. And now I want to look at the negation. So I've got this negation. So I want to negate what I just found. Since I'm at where I need to be, my truth table is done. All I'm going to do is negate the values I just found in P or Q. So true, 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 false. Now it's going to be false, 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 true. And that's it. These examples came from the Math and Society textbook by David Lippman. It is an open, free resource online. So if you're interested in further explanation or more examples, please check out that resource. So number 4, we're going to do the same thing here. We have P, we have Q, we have 2 simple statements. So we start by creating 4 rows and filling in true, true, false, false, true, false, true, false. And then we're going to add in columns as necessary. So I see a conditional statement. I see P on one side. I already have P, so that one's done. On the other side, I see not Q. I have Q, but not Q I don't have yet. So I'm going to add in a column for not Q. That's going to have the opposite truth values of Q, so that will be false, true, false, true. Now I have a not Q column. So now I can look at the conditional statement together. So P implies not Q. That's where I wanted to get, so I don't need the rest of my truth table. The conditional statement. Now let's go back up. This one is just a little more confusing than the others. So the conditional statement is false when P is true and Q is false. So if you have true, false, and it's important that you're looking at the order of them. The first thing is true and the second thing is false, then overall it's false. Any other time it's true. So for the conditional statement, true, false means false. It's always true otherwise. So I have P implies Q, not Q. So true implies F. True implies false. That is when it's false. Next I have T and T. So truth implies truth, that's true. Anytime the first thing is false, that's always true. So if P is false, the overall conditional statement is always true. The only time it's false is if you have true first and then false second. So that would be the first row. Other than that, all the other cases are true. Okay, our final example is another conditional statement. We have P and Q. We're going to set up our truth table. So we'll have true, true, false, false, true, false, true, false. So we have not Q implies not P. So we don't have either of those things. So we're going to add a column for not Q, and then we're going to add a column for not P. So not Q will be the opposite truth values of Q. So false, true, false, true. And not P would be the opposite truth values of P. So false, false, true, true. And now you want to combine those together. So we're looking for not Q. We have that here. Implies not P. We have that here. Okay, so now we can do the combination or the conditional statement. If not Q, then not P. So we're looking for the implication this way, right? Not Q implies not P. I'm looking for true, false. If I see a true, false, then that is false. In the second row, I have true, false. That's false. All the others are not that way. False, false, that's true. False, true, true. True, true, true. So the only one that's false is number 2, and that's because it has true first and false second.